The USS John F. Kennedy isn't just a massive warship. It's a floating symbol of power, legacy, and cutting-edge technology. Beneath its steel surface lies a marvel of engineering, a vessel that redefines how wars are fought at sea. But here's the big question. Do these colossal giants still have a future in a world dominated by drones, cyber warfare, and hypersonic missiles? Let's find out. During the Cold War, the U.S. built a ring of military bases around the Soviet Union, in Europe, the Middle East, and the Pacific, to keep Moscow's aggression in check. But after the USSR's collapse, many of those bases disappeared. Today, fewer nations are willing to host large American forces on their soil. So, when the U.S. needs to project power or take down threats like ISIS or Iran, it often does it from the sea. That's where aircraft carriers come in. These floating fortresses, packed with aircraft, weapons, and logistics, can deliver the same strike power as a land base, but with far more flexibility. The U.S. operates 10 Nimitz-class carriers, often called 4.5 acres of sovereign American territory. And for good reason. Each can launch over 100 aircraft sorties a day, for months on end. And thanks to their nuclear reactors, they can operate anywhere in the world, without ever refueling or relying on land bases. However, rivals like China and Iran have developed powerful anti-access systems to keep the U.S. Navy at bay. But here's the catch. While ground bases are fixed and easy to target, aircraft carriers are constantly on the move, shielded by advanced defenses and escort warships. Their layer protection makes them almost impossible to destroy. Even if hit, these carriers are designed to survive. Thousands of tons of armor, hundreds of watertight compartments, and both active and passive defenses mean that only a nuclear strike could realistically sink one. The Ford-class carriers, the newest in the fleet, can reach speeds over 35 miles per hour, meaning they could be anywhere within 6,000 square miles in just 90 minutes. No adversary on Earth has the real-time surveillance needed to keep track of that. In wartime, the U.S. Navy moves fast, wiping out enemy radars, drones, and targeting systems long before the carrier strike group comes into range. And when it does, the results are devastating. A Ford-class air wing of 90-plus aircraft, backed by AI-driven systems and smart weapons, can cripple an enemy's military power in days. Whether it's ISIS or North Korea, a single carrier can destroy over 1,000 enemy targets in just a week. Even if U.S. bases on land are compromised, history proves it. In Operation Desert Storm 1991, 6 U.S. carriers helped crush Saddam Hussein's forces before the ground invasion even began. A decade later, 4 carriers spearheaded the assault in Afghanistan. And in 2003, 6 more took part in Operation Iraqi Freedom. Today, the U.S. Navy's Fleet Response Plan ensures that several aircraft carriers are always on standby, ready to move, strike, and dominate whenever a crisis erupts. The Gerald R. Ford class aircraft carriers stand at the peak of modern naval innovation, the most advanced and powerful warships the United States has ever built. The U.S. Navy plans to commission 10 of these next-generation giants, replacing the aging Nimitz-class fleet one by one. It all began with the USS Gerald R. Ford CVN-78, the lead ship that took over from the legendary USS Enterprise, CVN-65. Only 5 names are public so far: Gerald R. Ford CVN-78, John F. Kennedy CVN-79, Enterprise CVN-80, Doris Miller CVN-81, and as yet named CVN-82. But the Ford was a trailblazer, a ship that faced every challenge imaginable from its construction in 2005 to its commissioning in 2017. Enter the USS John F. Kennedy CVN-79, the ship that learned from Ford's growing pains and took innovation even further. But what really sets Kennedy apart? Let's break it down. Construction on the Kennedy began in 2011 at Huntington Ingalls Shipyard in Newport News, Virginia, with the keel officially laid in 2015. Unlike the Ford, which relied heavily on on-site assembly, the Kennedy used modular construction, large sections built and fitted together in factories. This streamlined approach meant that by the time of its launch in 2019, Kennedy was already 70% complete, compared to Ford's 50% at the same stage. The secret behind that leap? Digital design technology. Every component was modeled and tested in a virtual environment before being built, reducing errors, cutting costs, and speeding up production. Both carriers are powered by the A-1B nuclear reactor developed by Bechtel, a powerhouse generating around 700 megawatts of thermal energy, about 25% more than the older A-4W reactors used in the Nimitz class. That extra power fuels everything from the EMALS, electromagnetic aircraft launch system, to advanced radar arrays, and even future weapons like directed energy combat lasers currently being developed with the U.S. Air Force. The A-1BS compact design also frees up valuable space inside the ship for equipment and easier maintenance, a win-win for performance and practicality. Now, let's talk about two of the ship's most critical systems, EMALS and AAG Advanced Arresting Gear. These replace the old steam catapults and landing gear, allowing smoother, faster, and safer aircraft launches and recoveries. Thanks to lessons learned from the Ford's test runs, engineers fine-tuned both systems for the Kennedy, greatly improving reliability and efficiency. Another major success story was the Advanced Weapons Elevators, AWE. On the Ford, these high-tech lifts, powered by electromagnetic systems instead of hydraulics, caused endless headaches, delays, and cost overruns. But Kennedy's team fixed that by redesigning key components, refining manufacturing, and using enhanced digital simulations. They solved the problems that plagued the Ford and made the system more reliable, faster, and easier to maintain. One more major upgrade lies in the radar systems. The Ford was fitted with a dual-band radar DBR, a powerful but extremely expensive combination of Spy-3 and Spy, for radars originally intended for Zumwalt-class destroyers. However, when that program was scaled back, the cost of each DBR skyrocketed to over $500 million. For the Kennedy, the Navy made a smarter move, replacing the DBR with the Enterprise Air Surveillance Radar, EASR, based on Spy-6 technology. This system offers advanced performance at a fraction of the cost, saving roughly $180 million, enough to fund nearly a year and a half of Ford's operational expenses. With its digital construction, powerful new systems, and cost-efficient upgrades, the USS John F. Kennedy represents the next leap in carrier evolution, smarter, faster, and far more capable than ever before. When it comes to cost, the lead ship of any class almost always carries the biggest price tag, and the USS Gerald R. Ford was no exception. This groundbreaking supercarrier set the U.S. Navy back nearly $18 billion, with $12.8 billion for construction and another $4.7 billion poured into research and development. Its successor, the USS John F. Kennedy, shares the same impressive air-wing capacity, built to launch and support up to 75 aircraft. That lineup includes C, 2 Greyhound cargo planes, E, 2 Hawkeye early warning aircraft, SH, 60 Seahawk helicopters, MQ, 25 Stingray refueling drones, S/A, 18 Super Hornets, and of course, the 5th generation F-35 Lightning II fighters. But integrating the F-35C wasn't simple. In fact, it caused several schedule delays. Originally, the Kennedy was supposed to be delivered in 2 stages, first with basic readiness, and later with the systems needed to fully support the F-35C. However, in 2020, the Navy made a bold move, shifting to a single-stage delivery to speed up deployment and get the ship combat ready sooner. Part of that push came from Congress, which, under Section 124 of the 2020 National Defense Authorization Act, required the Kennedy to operate F-35C jets even before its final post-construction upgrades. The other factor? The Navy's never-ending drive to save time and optimize resources. The single-phase approach avoided months of delay, but it also nudged the Kennedy's commissioning date from 2024 to 2025. In the end, the Navy got what it wanted, a faster, smarter, more capable carrier, though it surely cost more than a few sleepless nights for everyone involved. So, here's the question. When do you think the USS John F. Kennedy will finally set sail on its first mission? Drop your guesses in the comments below, and let's see who gets it right.